Imagine how boring life would be without colour. But where does colour come from? In this movie, we look at dispersion, which means the breaking up of white light into its colours. We all know about rainbows. Rainbows show the phenomenon of dispersion. Where do the colours in the rainbow come from? They come from the white light of the sunshine being split up into its component colours by the raindrops in the air. They come from dispersion. So white light can be dispersed into all these different colours. Dispersed means broken up into the colours. We call all of these colours the spectrum, or the spectrum of visible light, the spectrum that our eyes can see. The word spectrum means range, or we could say a variety, many different colours. And you can see there are very many different colours here. We could say there are 7 colours: red, orange, yellow, green, blue, indigo and violet. You probably know indigo and violet as purple, but actually there are more than 7 colours, because there are colours in between here, many different shades. So all of these colours were actually in the white light, which in a rainbow comes from the sunlight. The light coming from the sun is white, but it actually contains all these colours in it. But you don't notice that as the light just travels from the sun. But if there's something to split the light that comes from the sun into its colours, then you notice that actually there are these colours inside that white light. How do we split it? What can we do to get a rainbow? Here's a simple thing you can do. Take a CD. I've actually got 2 CDs here, and I've hung them from a tree in such a way that their shiny side is facing outside. So I have the 2 shiny sides facing outward. And you can see as the CD moves around in the light, the grooves on the CD split the light from the sun into its colours. So we can see many little rainbows. So the light is being dispersed into a spectrum of colours by the CD. Here's another thing you can do. You need a container and a mirror. Fill the container with water, then place the mirror at an angle inside the water. You can see that here we are close to a wall, and I've stuck up a piece of white paper on the wall just to make it clearer. Now move the mirror around. You will see that it reflects light. It makes a bright patch on the wall. Now you just have to get the angle right. Move the mirror around, try different angles until you find a rainbow. So you can see there, I have a rainbow. You can see the different colours of light. And a rainbow always has these colours: red, orange, yellow, green, blue, indigo, violet, in that order. You can see the red here and the violet, or you might want to call it purple, over here. The colours are never mixed up. It's always in that order: red, orange, yellow, green, blue, indigo, violet. You can remember this with the shortening ROIG BIV. Another way to disperse white light into its spectrum of colours is to use a triangular prism. You see, actually, anything that can spread the light out will do this. But some things spread the light more than other things, and so it's easier to see a rainbow. And a triangular prism spreads light very well because of the shape of the prism. So if you have a triangular prism, you can simply go outside, hold it in the sunshine, move it around until you get a spectrum. If you don't have a triangular prism, you can make use of a simulation to see this. So we open the bending light FET simulation. We choose prisms. We select the dark environment with a white light. We press our light on. You can see there we have white light. Now we take a triangular prism and we put our light on. Let's move our apparatus such that we have more space to see. And can you see that the triangular prism is bending the light in such a way as to separate the colours that are inside the white light apart from one another? So the triangular prism is dispersing the white light into its spectrum of colours. So we can see nicely here that at the top we have red, then orange, yellow, green, blue, indigo, violet, ROIG BIV. Raindrops do the same thing. So we have white light from the sunshine entering a raindrop. The raindrop bends the light, and it bends it more than once. just as the triangular prism bends the light more than once. And that magnifies the effect. That's why you see a nice rainbow with a triangular prism and with raindrops. So you can see the light is bent as it enters, and then it's bent back towards the same direction that it came from, and each time it's bent, the colours separate more, so that with all the bendings together, it makes a nice clear separation of colours to form the rainbow. So as you can see in this picture, there we have some clouds. Maybe it's been raining. We have a lot of raindrops inside that cloud. There we have white sunlight travelling to those raindrops. And here we've magnified what it looks like inside that cloud. There's just one of the raindrops. And what's happening inside there is that the white light is coming in and being bent and bent again and being bent back again, and at each point of the bending the colours are being separated further and further apart. Then here we are standing, and our eyes now receive that light that has been bent so many times and been dispersed into the colours. So when we look, we see the colours of the rainbow.